My name is Maria Sangiuliano. I am the senior gender researcher from the University Foscari Department of Computer Sciences, who has accompanied and supported the EQUAL-IST partners and universities in implementing and designing gender equality plans. So EQUAL-IST is aimed at designing and implementing gender equality plans in information sciences and technology research institutions. Here you can see our beautiful consortium and 7 universities who has really go through this challenging process quite successfully, I would say. So we designed gender equality plans using a participatory approach and using a crowdsourcing platform that we have designed and delivered within the project to identify challenges in a collaborative way related to gender inequalities in each research institutions. And we have then prepared a specific set of actions within the umbrella action of gender equality plans dedicated to make sure that we could increase the number of female researchers, improve their career mobility, and raise the awareness in general about gender equality issues in research. So the specific topic of how gender could be integrated as a research dimension in ICT and IST research projects has always been, let's say, the most challenging area within our project. So we have foreseen a dedicated area of intervention to this particular aspect in each gender equality plan. But we have reported we have been receiving the feedback from our partners that this was really one of the most difficult areas to work on. We actually managed to have just one JEP, including a specific action on this. And it was about creating interdisciplinary teams of scholars and researchers from both social sciences and humanities and ICT IST to work on projects of common interests. But then the general feedback from partners was that from their colleagues, it was very difficult to understand how this could really take place, how gender could be considered as a dimension when designing research projects, because ICT, computer sciences, information systems is positioned really and conceived as a hard science and considered gender neutral per se. And also there is a lack of both theoretical understanding, but also a lack of case studies and examples drawn on ICT and IST design. For this purpose, we have then worked out a toolkit on gender equality in IST research organizations. Within this toolkit that you can access online via our project website, we have included a dedicated chapter to gender in research content within ICT to provide further support to our partners and raise the awareness of this. And within the toolkit, we have identified 2 main areas of relevance. So basically, it is all about how users of ICT technologies and information systems, how users are actually attributed responsibilities, tasks, how their identities is conceived and imagined by programmers. without reinforcing existing gender divides or gender stereotypes. So we have used the categories of implicit gender scripts, which are also embedded in designing ICT and IST, drawn from feminist science and technology studies. We have identified a further area of interest to this topic, which is machine learning and artificial intelligence, as several studies have demonstrated that whenever ICT relies on web corpora and labels are associated to data sets, then there is really a strong risk that gender, racial, and intersectional bias might influence the design process. So starting from this, we have identified also our keynote speakers for today. Here you can see the agenda of our webinar. We are actually, I have to inform you that unfortunately one of our speakers, Chiara Leonardi from FBK, will not have the possibility of joining us. She's unfortunately on sick leave. The good news on one side is that we will have more time for the other two presentations, but also more time for interaction. As far as interaction is concerned, I would just want to stress that your feedback within this session is really, really extremely important to us. Because we will continue to work on providing more specific guidelines to ICT and IST researchers on this. So we will finalize, we will have question and answer sessions after each keynote. The way we would like this to work is using the chat box. So I would ask you to type your questions to the speakers. When you can start already when they are delivering their speech, and then they will answer right after their presentations to make it more interactive. Of course, there will be an opportunity to have the full recordings of our webinars, and therefore also the presentations after we have concluded it. I would like now to give the floor to our first keynote speakers, Professor Nicola Marsden from Heilbronn University, who we are also very proud of having her as one of the members of our EQUAL-IST advisory board. She's one of the really most renowned experts on gender and ICT design with a cross-disciplinary background, and she will speak about usability and human-computer interaction issues. Thank you, Nicola, for having accepted, and I would give the floor to you.
Thank you very much, Maria. Thanks. So welcome, everybody. Thank you for the invitation. I'm very honored to be here. I have slides, which I'm not entirely aware if you can see them or not. I am very excited to share some of the work that we've been doing on gender bias in ICT. And the way I have structured this is that I would, first of all, talk about what does gender bias in IT systems actually look like, and then differentiate the different kinds of biases there are, and lastly, think about what can be done about it. So maybe for just a brief definition of bias, we're talking about something being slanted, so talking about not treating like cases alike, so treating cases that are identical the same, or unfairly discriminating against certain people or groups of people. Important is that the IT system would have to systematically do this, not to everybody. That's of course where it starts to be really difficult to recognize, because we usually always see one case, so we never know whether this is really systematically or just a coincidence. Let me start with a personal story maybe. A while back I had a tumor in my head and I had to have head surgery. They had to actually saw my skull open. And needless to say, I was very nervous when they pushed me in the operating theater. And when I came in there, they looked at the IT system to see which operating room I needed to be in. And they put me in it. And so what happened, they came in and they had put me in the wrong operating room. They were all freaking out about this. And what had actually happened was that the nurse at the beginning of the operating theater had not pushed the refresh button on the screen. The nurse was almost in tears, and here for some reason was me calming him. It was a man down telling him that it was not his fault, but it was actually the system that was at fault, that it shouldn't be that something this important shouldn't refresh itself. So my thinking about what this has to do with gender kind of resolves around the question, okay, was this a coincidence that this part of the hospital system that the nurse was working with had such bad usability or not? So the basic question here is, would they have made the system better if it was for somebody else? And I think this is already a very important question to think about when you're thinking about bias in ICT systems, because as always with biases, I'll never know whether it was this one case or there was really a bias. But you see it has to do with power relations in society, which of course are also reflected in gender and gendered professions. So basically what we're willing to invest to make a system usable or not depends on the power that a certain user group has, which of course is very closely related to gender. So gender bias in IT systems, and another example here where we have data to show that this is actually biased, and it's a platform called Fiverr. It's a platform for freelance services. It's very straightforward. It does exactly what you expect a system like that to do. Okay, so if you're looking for a service, you type in the requirement in the search field, the system searches the database, it matches requirements, retrieves all reasonable options, and displays these options in a list, orders the list by what others had good experiences with. Obviously, some are going to be visible, others you have to scroll down to get to. So now there is studies that show that the results of this platform actually have a gender bias. If you're looking at this, you will see that results of women service providers are systematically rated lower than male service providers. If you're looking at it from an intersectional perspective, you see it's even worse there, which of course is, let's just say, shocking. If you're familiar with gender research, you might say, well, this is just a bias that exists in society and that we have here. But yes, but I want to argue that the system also has its role in discriminating women on the platform. The way the software works actually enhances and manifests the bias. If we're looking at what an interface does, it compounds the bias by giving it an order, by making visible what actually otherwise would be invisible. And the advantage for the service providers to be at the top of the list obviously is enormous. We don't know numbers for this platform, but other platforms actually show that 90% of the sales, for example, go to the search results on the first platform that you don't have to scroll down, but on the first screen that you don't have to scroll down for. And also it's unfair to the users, because if you're thinking about it, they have good reasons to assume that they're being informed in an objective way, when actually the results are slanted towards white men. So we find this in other platforms too. This is TaskRabbit, also a service platform that offers freelancers, and here we find that women get 10% fewer reviews we find that women are ranked lower in all categories. So it's important to realize this operates actually through a functionality of the system, through reviews, through rankings, and they actually are what makes the gender bias materialize on the platform. We also find this actually in terms of looking at what men and women are paid. This is also then differentiated on the platform. So if you're wondering, okay, what does it actually look like, this gender bias, then we find that it looks kind of unsuspicious actually. Oops, sorry, that was too fast. It looks kind of unsuspicious usually. It looks like system, they're just doing what they are supposed to be doing. Just something else is also happening. They're also doing or making a gender bias. The next point, I want to look at what kinds of biases are there, referring to the framework here of Batja Friedman and Helen Nissenbaum, who differentiate pre-existing bias. So in the case of Fiverr, for example, that'd be women's work is valued less. And then technical bias, where we have the functionalities like order, like ranking criteria, like reviews, like scrolling, that actually materialize the bias. And then we have emergent bias that is resulting out of the use and affects different users. Let's have a look at those. If we start with the pre-existing bias, then we know that, of course, discrimination is something that is part of our social makeup. It often happens implicitly, like Maria said before, and without intention, so we don't have to be prejudiced to discriminate. This is actually something that modern stereotyping research has shown us. We don't need a negative attitude. We can be totally tolerant and still discriminate because there's this pseudo-knowledge, these implicit knowledge structures that we have. So one of the first studies that was done here in this area looked at the orchestras in the United States, which of course are big business, so they are interested in hiring the best. And for some reason, though, these were all men up until the 70s, when they actually started to do blind auditioning. So once the people that were auditioning for the orchestra were playing behind a screen, and it didn't matter whether it was a man or a woman or an Asian person or whatever skin color a person had playing there, that's when actually women started to also get a chance to come into these orchestras. So what's happening is we're looking, or in this case hearing, the same music, but how we perceive it depends on who is playing. So that, of course, is the pre-existing bias that we find here. At Fiverr, we have that too. We had the identical work, but with one person we see good work. With another person, it's not good work. And the software is actually materializing this through the ranking system. So systems are only as good as the people making them, and as I've said, we're all full of these implicit knowledge structures, which are also materializing, as we'll hear later, in the artificial intelligence. So, for example, here, there's knowledge that we connect men to computer programmer as woman to homemaker, and those kind of things are something that is, in terms of pre-existing bias, there in all of us, me for sure, probably you, and it doesn't need us to be prejudiced towards certain groups. If we're then going to the next bias, the technical bias, so this arises from technical constraints, from technical possibilities, restrictions, from the hardware, software, the screen size, the number of fields in the database, the need to put things in an order, the functionalities that are implemented. Then if we're looking at order, for example, here I have an example of a search that's the German word for executive board, and it's put in an order, and just so happens that all these pictures on the first screens are showing men. There's another search example here where I search for nursing, and nursing, it just happens that on the first page all we have in this order here is females, which in turn, of course, we know once again affects people that are seeing it and affects the images of professions and so on. So this kind of leads us into a kind of vicious circle, if you will. Another example for technical bias, of course, the technical bias is often in the interface. What we find here is the gender binary in this pull down from Ryanair, where you're supposed to enter your title. The gender binary, of course, is already a sort of a form of discrimination because it's excluding certain groups. What we also have is there is an order here. It's Mr. first, Mrs. next in the example on the left. And this is also, did a little study on that and showed that this is something that happens just a lot, let's just say. And I have these two screens here because another thing that that can lead to bias is localization of software. You see this was translated, and you see that for the title there were 3 options given: Mr., Mrs., and Ms. And you might maybe know that Ms. could be seen as some kind of feminist achievement to actually have that as a title that doesn't reflect the marital status. But you also see what they were doing here when they were translating it, because when they were localizing it, they had this database, they had 3 options in there, and they turned the Ms. into Fräulein, which you might know is the most old-fashioned way, backward way of addressing females in German, or unmarried women in Germany. So I don't know, I can just hear them talking about it. So it's like, well, okay, it's not exactly, but hey, we need 3 options, so this should kind of work. So this is something that happens here as a technical bias. Rina Bevan's done amazing work and examined the 56 gender options that exist on Facebook. You might have heard about that, and showed that actually in the depth of the database, these are all recoded into gender binary or binary and other classification system. That's why she called her paper here, the gender binary will not be deprogrammed. So these are examples of technical bias. If we're coming to the last one, the emergent bias, then that's the bias that results in the context of use. So offering older people devices that require fine motor skills, for example, or having voice recognition that reacts better to men's voices would be examples of emergent bias. Another emergent bias here, Apple has been criticized for making phones that are too big for the average woman's hand. So there are certain things that people with smaller hands can't do with it. Another example of emergent bias here is that certain user groups are configured as the exception. This is a German platform for children with games. And here we have all different categories of games, and then we have girls as a category. So of course, this is communicating that all the other games are not for girls and reinforces the male default on this platform. Another emergent bias example here is LinkedIn, which has been shown to have a gender bias in the job listings that then actually affects or has an impact on who applies to which job. So these are the 3 kinds of biases that we have: pre-existing bias, technical bias, and emergent bias. And now I would like to go to the question, okay, what can actually be done about it? Our approach is to look at the ICT development process and see what can be done in the different phases, which interventions, which tools you can kind of use within this process. Others, Claude Raude and Susanne Maas, are doing amazing work here using process models, which of course process models are very popular in software engineering, and using them as a starting point for gender interventions. So what we're doing, we're working with ISO norm for human-centered design, and I just would like to highlight a couple of areas here where you could intervene or use certain tools and give some examples here. So if we're looking at the first phase, this is about understanding the user context. And the idea is to have gender equality by design. So make sure that it's in there in the beginning of the process, of course, that means that at the very beginning you ask the right questions to find out about the user context, or ideally, of course, you let the users participate. It's let me give an example. We're working on a platform here for female IT professionals, and asking the right questions. I could tell you what is not the right question to ask is, what could we do to make this attractive for women, for example, because that's going to be for sure something that would elicit stereotypes. So once you make gender salient, and that's one of the problems that you have trying to integrate gender into the process. Once it becomes salient, there's always a great danger actually of stereotyping happening and of this pseudo knowledge being applied. So instead, of course, it would be better to involve future users in terms of co-design, in terms of participatory processes, to prevent what's called I methodology. So I methodology describes this fact that that design teams or developers have a tendency actually to take themselves as a starting point, trying to figure out what others want. So as if through introspection you can kind of figure out what others want. It's got different names. Karen Halsblatt calls it like the design by the I, which the I is myself, or the ego approach, but this is something that is very problematic and a big issue in software development. So here it's about asking the right questions, involving the users, and also making sure you get qualitative data that's gathered in a real context of future use. Of course, Karen Halsblatt has done groundbreaking work here with what's called contextual design. But actually understanding the context of use goes further than what the users can tell you. If we know that there is a pre-existing bias, then the question, of course, is, do we not have the ethical obligation to take into consideration what it is and to counteract it? Let me give you an example from an emergent area, which is we are at many places now designing systems for the collaboration in virtual reality. And this is our big chance to create a new world, of course, because we know, like in face-to-face situations, women get interrupted more often, they're judged on their looks more often, they are usually shorter, which automatically leads to attributing less leadership attributes and things like that. And the question is, what are we doing with that when we're building virtual reality collaboration settings? The studies actually show, if we're looking at this, that's the Proteus effect that's cited here. If you give people a taller avatar, a taller representation in this virtual environment, they will display more leadership qualities. You give people a friendlier, a better looking avatar, they will behave more friendly towards others. So this is also part of the context of use and should be taken into consideration. One way this has been tried to put into action is trying to create team avatars that actually then are morphing and are morphed from the people that are in the team and then merge together as to create a common team identity by having a common avatar. And this is actually something that that does work. So if we're going to the next phase here, the definition of requirements, like I said, it's best to let users participate. If this doesn't work, they should be represented in an appropriate way. Representation, if you're looking at users, they are very different from one another, and if you're representing them, you have to think, how am I representing them and who am I representing? There's a method, a tool that's very popular called personas, where actually you're creating fictitious characters that are representations of the future user group. But as you might be able to imagine, this is something that is also very prone to to being made in a very stereotypical way or being used in a stereotypical way. If you say, okay, and so this is the older person and then this is the female in the persona, said there's a great danger that once again stereotypes come to bear. So one thing we're working on is trying to see how can we work with multiple identities and their intersections actually to develop personas. So we identify identity themes and then extract them and put them together in a way that non-stereotypical personas are created. So for example, the person that has the persona that has children is also the one that is most career oriented or something like that. So the next thing I wanted to talk about would be the prototype and then how you evaluate it. And here also with personas, but another approach, Margaret Burnett and her colleagues have done important work here and developed an approach called Gender Mag. And what it does is it focuses on the facets which differentiate, where differences have been found that actually cluster by gender. So for example, tinkering is a facet or an approach to software that has been shown to cluster by gender, in the sense that men tend to tinker more than women. And what they have developed is a cognitive walkthrough, so a very structured step-by-step method to look at every functionality, every step of my software to figure out whether it supports all kinds of users well, or whether there should be something else done to make sure that it does support all users well. So this is a very structured and a very interesting approach to find gender inclusiveness issues in software that is already there. So in each iteration, it's important to reflect on possible gender issues and to fix them. This might seem trivial, but I do want to say this: if you do not look for them, chances are you will not find them, because of the way implicit cognitive processes work and of the complexity of software systems. So no matter how many iterations you've made, there will be probably emergent biases. So it's important to actually monitor and improve the software that you make. One example where a system was actually improved from a gender inclusiveness perspective is LinkedIn. They had an algorithm that prompted auto-completion based on the frequency of names. At least I assume that's what they did. So that means if you were looking for Stephanie, you might be asked, okay, did you mean Stefan? And this was actually something that was brought up by users, and it was changed then by LinkedIn. So this is about monitoring and fixing it. So there's a lot that can be done in the process of research and development in ICT, and it's important to keep an eye on the gender inclusiveness and avoiding discrimination really throughout the process, in all phases of the processes, because of how biases work, there's a very high chance that discrimination can creep in at any phase. So if you think that we're actually with our IT systems building the world of tomorrow, that is a very big lever we have to actually make sure that this tomorrow is fair and non-discriminating. So with that, I would like to come to the end. I've showed you that gender bias in ICT can be very unsuspicious, that you have a straightforward system that seems to be only doing what it's supposed to do, and still it's actually biased. In differentiating the three kinds of biases, I showed how pre-existing bias can materialize through the technical constraints of a system, and thus lead to further biases, so emergent biases, and in a vicious circle, basically enhance gender discrimination. And so finally, I've suggested some interventions and tools for the IT development process to ensure gender inclusiveness, and would just like to close with the appeal for everybody to make sure they design for gender equality, because this is our chance to make sure that the digital turn leads to a gender fair and inclusive world. So with that, I'd like to thank you, and am looking forward to your questions.
Thanks a lot, Nicola, for an extremely interesting and rich presentation. You already have 2 questions, actually, and quite interesting ones, if I might say. So, both from ICT, from information system researchers, so from the discipline, let's say. We have Armin, who is asking you, we are looking at the user interaction and how developers often disrespect the diverse user groups during ICT development. Here, I can definitely envision to sensitize researchers to take this into consideration during their research. What about, for example, researchers working on the JPEG algorithm or any efficiency-driven thing that per se are independent from the user's group, make no judgment, decision, etc. Would you agree that there is research that doesn't have any gender dimension in it? If not, how can I integrate a gender dimension if my research has no user dimension?
Thank you. All right. A very, very interesting question. And I actually try to kind of hint at how you could think about that with my first example, where I was saying that if you have a system and the question is, would you make the system better if it was for somebody else, for example? So the surrounding of the system, so it starts with who is it made for, why is it relevant, why am I making this system and not another system? And if you make the picture that big, there usually is a gender dimension. Once you're already in the small of saying, okay, now what's the next step and what's the next step, I totally agree. It's very hard to see what gender has to do with any of this. But I think the question, okay, let's make the picture a little bigger and see what we are doing here from the very starting point. Who is actually commissioning this? Who wants this done? Who are we serving by making this system is also a question that that is relevant and ethical and typically has a gender dimension. That's the one thing, and from coming from the beginning of the development process. The other thing is that I try to point out that a lot of times we don't see the gender dimension because we don't have all the information. We just see this one instance and we don't know if this is systematically doing anything. So I think a lot of times you really have to get data and figure out, okay, maybe this is affecting males and females differently. Let me give you an example for something that seems very straightforward, which is the SAT. The SAT is a college placement test, or a test that pretty much all people who go to college in the US take. And it's a multiple choice test, so it's probably the most important test a teenager in the US would ever take. And this was very straightforward, of course, algorithm. It was just checking whether people were answering the question right or wrong. There was a punishment for wrong answers, and then you got results that just so happened were much better in math for men than for women, for example. And to just say this very briefly, there was research done then. Okay, what happens if we take away this this punishment for wrong answers? Maybe it is that females are more reluctant to guess. And what actually happened then, once they took that away, and they did studies parallel and could show that that with identical knowledge, women would do better on the tests without this punishment. So this is something where nobody had any intention there to be biased, and you just need to have this perspective and looking at it and getting the right data to figure out, okay, this actually is affecting different genders differently. So I hope that kind of gives some ideas how you could go about that, even if it doesn't seem like it's got anything to do with gender.
Thanks, Nicola. We have one more question from Elena Gorbacheva, who asks you, you have mentioned a challenge of falling into stereotypes once we try to address a specific group. For example, if the goal is to engage more women in the IT profession, do you have any recommendations on what actions could be done to ensure not falling into stereotypes when we need to address specifically women? That's very interesting. I actually had a question on this. It's on the design for women trends or approach, which can be risky in a way.
Right. Yes, absolutely. This is a very, very good question and a very tough question because of just that. You know, whenever you address gender, you get what we know as self-stereotyping and stereotype threat. Actually, we know that women do worse on math quizzes if they get asked their gender first, and these kind of things. And of course, a lot of times you get reactants. People are like, why should I be different? I don't want to be treated differently, which of course is very true. I think what's important to realize here is the differences come from the way men and women are treated by others. So if you're looking at teams that have a certain makeup, then if you have one woman in the team and 5 men or something like that, the situation for the woman is different from the very beginning. So I think one lever that you have, one starting point to actually get women in, is trying to give them that experience that that a lot of men have in that environment, is that they just fit in, that they can just be there without being questioned, that they have like-minded people around them. And this, of course, has organizational consequences. If you want to think this through, it would be you don't put one woman on each team, but you actually put them together and make it kind of like a little breeding point for more women, or an attractive point might be a better word for that.
Thanks again. Any more questions to Nicola from our participants? I would have one. If you could maybe tell us something a bit more on in the intersectional dimension within gender bias. You referred to it actually during your presentation already. Would be interesting to hear more from you on how it could be actually taken into consideration. Sometimes I heard about like comments that it is already included into design for all perspectives or approaches, but I'm not entirely convinced about it. How would you frame it?
All right. Well, I think the important thing that the intersectional perspective shows us is that that different categories of difference, actually, when they combine, they can create a new kind of situation, let's just say. If you remember, what I was showing was, for example, that in Fiverr, the bias against Black females was much stronger than against females. So or then against females by themselves, or Black people by themselves. So this, of course, is the prototype of what the intersectional lens shows us. That when you have an addition of different categories, then they can intersect in a way that creates a stronger discrimination even. And I think I agree. I think this needs to be looked at individually, or for each instance, or be taken into consideration for each instance, because they are different. Somebody looking at the presentation, and so that's what I was referring to. Also to that in the personas that we're making right now, or that we're experimenting with and working with, to kind of prevent personas from being so stereotypical as they often are, and actually try and point to these intersections and take them into consideration and make them visible through personas. Because I do think once we have these very specific cases as something that we're looking at, other cases would already be easier, let's just say, rather than the other way around. I don't think with the broad categories of males or females or something like that, we're dealing with these specific intersections. But the other way around, I think it would make more sense to say if this is something we've considered, then probably we're doing good with general categories of men and women too. So I don't know if that kind of gives you an idea of where I stand there. Yeah.
Thank you. Maybe just a very last question. Would you tell us something more about, I was very curious to hear something more about the ISO norm on gender design.
Right. No, right. Unfortunately, this ISO norm is not on gender inclusiveness or anything like that. It is just one of the standard procedures for human-centered design. That is this iterative approach, you know, where you have these different phases. And what we're doing is we're taking that to look at the different phases and figure out, okay, in this phase of context of use, what do we need to take into consideration from a gender perspective? But the ISO norm itself doesn't have that in it. We're just using that as a vehicle to kind of transport the tools and the questions that we think should be asked there from a gender perspective. And that's something we made guidelines on, and like I said, Claude Raude and Susanne Maas have taken a similar approach, just taking standard process models, which of course are very popular in IT, and using them as vehicles to kind of say, okay, and if you're in this phase, these are the questions that you should be asking. These tools are the ones you should use if you want to include a gender perspective and want to make sure that you're considering where you might be discriminating or where you might not be fair. But the ISO norm itself is unfortunately not about inclusiveness on gender.
Okay, thank you. Probably is slightly misunderstood. Maybe in the future you might work out a dedicated ISO.
Will do.
Okay. Thanks again.
Thank you so much, Maria. Thanks.
Thank you very much. I would now give the floor to our next keynote speaker. So let me introduce you to Kalapriya Kannan, who is from IBM. Thank you, Kalapriya, for accepting our invitation and for connecting from New Delhi, actually. Kalapriya is a specialist on artificial intelligence system and distributed systems with a lot of working experience, a long track of publications and patents, working at the IBM Artificial Intelligence Fairness Team 360. She will speak about bias in reality. This is the title of her presentation. Kalapriya, please, the floor is yours.
Okay, so all set. Good morning, good afternoon, good evening for people joining from different time zones. And it's actually a good evening to myself joining from India. Okay, so I'll just give a brief introduction about myself, or maybe not more than a couple of lines, and then I'm going to switch on to the plan we have for today. And at the end, I'm going to introduce a tool that we have developed in IBM Research called IBM AI Fairness Toolkit, which basically looks at identifying bias at different stages, and it can also give you a mitigation plan for that. So let me introduce myself. I'm Kalapriya. I think and Maria has given a very good introduction about myself. So I work for the IBM Research India, and my core interests are in distributed systems, and currently I've taken up AI systems too. We have been looking at developing sophisticated AI algorithms to delivering them on AI platforms on large scale. So that's primarily the core interest from our research group. And today, the plan, what I have in place for everyone is that to look at what do we mean when we say bias, more from the perspective of AI systems, that is looking at an AI pipeline. What do we mean by bias? I'm also going to walk through a similar examples like the earlier talk that we had seen. We will look into bias, and I'm going to give some personal experiences where I seriously might have not noticed before I knew what bias was, but since I know now what bias is, perhaps now I can say that it's basically an it's due to the bias in the system itself. And then we are going to look at the toolkit, and a few definitions around how the toolkit works. And I would definitely urge people to look at this toolkit and see how you can use it in your research work. So saying that, I'm going to look at walk through a very simple example of how AI pipeline would look like. The reason for introducing this at this stage is that I think as people we should understand how an AI system works, what are the areas where the bias can get introduced, and if it gets introduced, what is the plan we should have in order to mitigate them. Okay, so this is coming more from the AI systems itself rather than the environment that surrounds that. So let's look into this AI pipeline. It basically says that there is a world and there are sensors that capture certain information from this world. Which is basically what we call it as data, and this data is fed into a model, and the model actually does a few predictions, and from the predictions we are going to help actuators, that is people who apply these predictions back into the real world. So let's take an example of a management system and employee management system. So in that case, the world is basically a set of employees. The events that the company records about the world is basically the sensors. Now this is where we need to be careful, because the sensors need not capture all the information that is available in the world, or it can selectively capture information which is representative of what it thinks is required to do certain operations. So these are potential sources where bias can get introduced. The data is fed into the model. There can be transformations of the data which can lead into certain information. So a model in this scenario can be something like it's going to predict how to incentivize people to perform better. So in such a model scenarios, it can happen that it is applying certain kind of algorithms to categorize people, and based on the categories, it's going to predict a few suggestions which the HR department and actuator can actually apply back to the world. So we are going to revisit this diagram back and forth because this is very crucial to understand how the AI systems works. And then based on that, we are going to introduce definitions of bias from the perspective of the AI systems and take it forward from there. So where are we applying this AI system diagram that we said? So if you look at this chart, it basically Okay, so we have a bunch of applications in AI, and every AI system that we write today has to go through that AI pipeline, and that AI pipeline is going to be very carefully decided for each of these applications that you see, and make sure that it is actually free of bias. Now we're talking so much of bias, we say that there is bias, we show, and we just wanted to understand why it's so important. I mean, bias is so important. That leads us to the question of saying that, so if you look at human beings, right? Human beings revolves around certain decisions, so we are constantly getting decisions from entities around us. Now, if you look at AI systems, so they are critical in influencing these decision-making processes. Like, because they always give us suggestions, they predict a few things and provide us information on which we can make certain decisions. Now, if a human system is assisted by an AI, we would like to ensure that this AI system provides you an unbiased view of the system so that you can make a careful decisions on that. Okay, so that is why we are so interested in seeing how can we make this AI more bias free. Okay, so the connection is that we wanted to make system close to human beings taking correct decisions. And because we rely on the AI systems to provide the decisions, we want the AI systems to behave unbiased. Now, certainly we should not forget that humans are the center of the AI, which means that most of the decisions that we take or the intellectual tasks that the AI systems can model are far from actually mimicking the human beings. But nevertheless, given what the system is today, we would like to understand how bias plays a very crucial part in decision-making systems itself. Okay, now the question to ask is, what does it take to trust a decision made by a machine? So this is what we call as 4 pillars, and I'm going to just walk through it briefly, and what we are going to look at is just the first part of it. The question to ask is it fair? That comes under this topic of bias. The second question to ask is it easily understandable, which comes under a topic called explainability. The third one is, did anybody tamper with it, which is basically called as the attacks or any change in the system, which is also falls into the category of adversarial attacks. And the last one to say is that is it accountable? What it essentially means that is, if there is an outcome that has come, are we going to make the system accountable for the result that it has provided? Now, we have set the context that bias is important. Humans are the center. We wanted to make an assisted system which is unbiased, that humans can take informed decisions about it and unbiased decisions on it. So all the setting about what bias is set, and now we probably are at a stage where we can define what is bias. Now, the bias is something which says that if there is a group of people or a privileged group, and you place them as a systematic advantage over other set of category of people called the unprivileged groups, then it is called as an unwanted bias. Now, let me give you an example of that. This has actually happened with me in the recent times. So one of the recruiting agencies called me and said, can you send me some referrals in resumes? And I said, yes, I can. But before I could ask what is the skill set they are looking for, the thing that he mentioned was that we are looking for male candidates. Now that was intriguing to me, because I was going to ask back the question, why would you look at male candidates but not female candidates? And why is skill set not important but a gender important? Well, the answer he gave back is that we are looking for candidates who can work off time, not the regular office hours, and we think that male candidates can do this better. So it looks to me like this is actually an systematic bias, because if you look at it, I would be equally eligible like the other person for getting the job, but just because my gender comes as a forefront to making the decisions, I'm at a systematic disadvantage for that. So this category of things is probably called as a bias. Now, if this has happened before I had started working with bias, I would have just ignored it, saying, okay, fine, it just doesn't match what I am. But now I understand the fact that it is basically because of a certain kind of a mindset, a certain kind of learning the person has done, that a female person cannot work off times, rather than asking the person whether he or she would prefer to work off times. Okay, so that's an example of an unwanted bias. But I'll also talk about the other factor. Where does it come from? It comes from your training data. It comes from labels. It comes from the models, the way it is being trained, what kind of features got into it. Most of the things are attributed to these, either the data or the model, which is basically core component of this AI pipeline. Let me give you another example. So when I presented the same work in one of the universities, a person got up and asked, see, I actually filled in 2 forms for insurance. Everything remains the same because it's just my mom, and we don't have any history of diseases, nothing's very clear, but my mom's thing got rejected. So then I asked her what could be the reason why it was rejected, what was the reason that the person got from the insurance agency, and the person said that it's basically because my mom's age is about 65. So this looks to me like, now the person asked me the question back, would you call this as a bias or would you not call this as a bias? Well, of course, looking at it, it is actually a bias towards a certain specific category of individuals, which is age in this case, turns out to be age. But look at the business perspective of it, right? The person is basically trying to maximize the cost that he could actually retain within himself. And one of his learning things, or looking at the history of what he has, tells him that above a certain age, it is very risky to issue insurances because there's a potential loss that he might incur. So there should be a very careful balance between things to define, and it might be completely dependent on the context, but a bias in general sense is bias, and I think we should look at how to mitigate. Okay, now I'm going to go through a couple of examples of the bias. The ones I gave is from the real scenarios that I have looked at. And here are a few examples that we have seen that gender or any of the categories like a race becomes potential in terms of deciding a discrimination. So this is an example of an online ad discovery tool. So supposing you go and give a search for the name called Sweeney Latanya, the first couple of things that pops out, if you look at the left-hand side, it actually says it's arrested. Basically, what it has done is it has looked at the name, and in certain fashion, it is associated that this could be a female of certain of certain race, and therefore it attaches a few words that is possibly sensationalizing the search result itself. But if you, the actual fact means that when you actually click at Latanya Ferrell, they did realize, going to their website, that there was no record for this person at all, which means it was just created for the purpose of sensationalizing the delivery of ads. On the right-hand side, on the other hand, was a search given for Christian, and the first couple of things that came up was not related to what he was actually, because when you click these records and you go into their database, it was found that these people basically had criminal records. So it should have ideally said that, when you search for Christian, it should have said Christian arrested, and for Latanya, it should have said something else if it was not in the database, right? So these are kind of discriminations that has gone into some form of an algorithmic bias into the system. I think this is a very popular thing that people would have seen. This TAI, I think TAI was a chat box introduced by Microsoft, and within hours of it being in the internet, people started posting discriminatory messages, and TAI had to learn those discriminatory messages, and it became eventually producing offensive languages in the internet, and the Microsoft had to pull it down within 16 hours. So this is another classic example of how system gets trained with the data that is available into certain category of bias segments. Now, the other example is that a criminal recidivism risk. This is basically, recidivism is basically predicting whether an individual who has committed a crime has the potential to recommit the crime or not. Okay, so if you look at the North Pointies assessment tool, it predicts 61% of the time right, but if you look at it for the African American, it says that the risk is very high when compared to the whites, but the actual data shows it different. And what the actual data shows that when the blacks get arrested, the probability that they commit the crime second time is less compared to the whites when they get arrested and they commit the crimes for the second time. So, you know, these kind of things which are very critical for making certain decisions in terms of providing a certain privilege to a person, if it is biased, can lead to some kind of decisions which are not appropriate. I think I will just quickly go through a few other more examples. The examples are picked up primarily to say that the bias itself from the data can come from something called as the protected attributes. And the protected attributes, while it's context sensitive, there is also some kind of generalized notion around it. And these protected attributes, or in these examples, if you look at it, it is predominantly gender, race, age as one of the factors. Income groups can be one of the protected attributes. So the key to the bias is basically identifying this protected attribute, which basically causes these algorithms to create the bias in the systems, and then trying to see how those biases can be brought on by the system. So the predictive policing is another example where basically the police officer, when he looks at whom to retain to make an investigation, chooses a dark-skinned person compared to a white-skinned person, and this has actually been noted in this algorithm, the PredPol algorithm. And now the interesting factor about these things is that the learning actually reinforces that, which essentially means it keeps learning and learning that you always look at detaining a black person compared to a white person. Okay, so this is another example of where a protected attribute called race plays a very important role in making the algorithm biased. This example, I think, was done in the earlier discussion also, that these word embeddings, you know, when you want to map certain terms to other words, you know, man to a king and a woman to a queen is what is normal, but on the right hand side you will also see that man to women is a computer programmer to homemaker, and it also gives you a set of occupations that a woman typically occupies and a man typically occupies. So there is a clear differentiation in the way women are perceived to have professions outside compared to the men. Now, this is no different than one of the work that we had done in our lab, basically where we actually took at movies, about 4,000 of them, looked at what kind of things, you know, the females have compared to the males. Now, certainly, if you look at it, the right-hand side, you know, it says that, you know, they are poor, rich, wealthy, honest, whereas the right-hand side says beautiful, attractive, and other kind of things which are clearly discriminating based on the gender. Now, certainly, as a female, I would like to be in the female bucket, but I also prefer to be called as a wealthy or an honest, and that is where this discrimination plays a role. You know, I mean, when it is not supposed to categorize me into only one bucket and have a perceived information about that person in that category. So definitely, it is good for me to be in the female bucket because I'm a female, but I also would prefer to be called as wealthy or strong or rich. So this has been in our society where women are perceived into certain class of perceptions, where it is clearly different than what male people have in the industry, which in turn affects careers, professions, and so on and so forth. Another example is basically a gender classification tool itself, which IBM had. And when it came to dark-skinned female faces, I mean, the available algorithms completely failed on them. leading to high error rates, and IBM re-put the algorithm with a new face recognition tool, and it could perform less than 3%. So basically, learning on white and learning on dark had completely different set of things, and it could really not match the requirements of the dark-skinned female faces. So in summary, what I would like to say from the beginning to here is that if your intended use is to have discrimination, then it is really good. It will increase your productivity, it will overcome human biases, etc. And I'll give you an example of that. Like say, for instance, if you walk into a women's clothing store, which is for women, and you are having only women clothing in that is a perfect bias, because it is a women clothing store, and you would like to have women dresses in that. But certainly one cannot say that, oh, I found a women's clothing store, but I could not find a male dress in that, or a male tie that a male candidate can buy from that. So that's an example where we are saying that a buffet bias is perfect, because that's the business requirement that you need, or the intended service that you want to provide. Now, as we have seen in the earlier talk, biases are often found by accident. If you're not aware of the bias, probably you would just let it go, saying that yes, this is yet another case of one of things which you may not want to focus. But it probably, the stakes are high. If you know that there is a systematic bias, then it can lead to real injustice, as there are many examples that we see, like in terms of loan, it just because there is a race associated with that, or a gender associated with that, the credits are not equally distributed across the different distributions, and it can lead to significant public embarrassments. One of the examples is the DAIS itself. So today, the topic of bias has been there for quite long, but it has gained interest in the industry now and academia, because of the wide adoption of the AI itself and the growing interest in the areas adopting AI. So this is something which I would like to highlight as part of the examples that we have seen. And I think we are going to the next phase of this thing. We are going to look at this AI pipeline. We are going to look at what are the different kinds of bias in that, and what is our tool going to do with these biases. So why do we care about bias in the AI system? I think I've going to reiterate the point that I made earlier, that humans are in the center of the value system. Our mission or our goal is to have certain values. And now values, if you don't have any values, nobody is going to trust you at all. Now, when you are making AI systems which are closer to human beings, you would preferably want the AI systems to move closer to the value chain. Therefore, you can trust the systems with greater confidence. So that's basically the reason why we wanted to keep AI systems unbiased. And I'm going to revisit this thing from the whole thing of that where are the things that the biased things can come into picture. So the world does not reflect our best values. It could be possible that the world that we are considering for the modeling purposes is not getting the best of the values that we have. The perceptions can be biased. So you're going to pick up a few things from this world and model them. So you decide what are the kind of events that you wanted to pick up, and therefore there can be bias in that. The senses themselves have limited capability, because you are modeling the senses and you are going to pick up what you want. The data therefore produced by these senses can be biased, which means the models which are learning from this data are certainly going to be biased. The models can make certain inbuilt assumptions. It can say that if my unseen data has these kind of fields, I'm going to react like that. So the assumptions that you make within these models can lead to biased predictions. And the actuators are also limited by their field of action. Therefore, they can be biased in the actions that they apply on the real world also. So if you look at this AI pipeline, the potential or the possibility where a bias can be introduced to this system is at every stage, and we need to have algorithms that deal with every stage of this pipeline to de-bias them. And that is what our tool AI Fairness Kit talks about, and it aims at basically mitigating the bias in the data. Okay, so the real question is, are we biased at all? Do we still, have this problem of bias in this thing? I think some of the examples quoted in the earlier talk was really nice. And here are a few things which also says that if you look at the Uber, they found out that if the call comes and if the voice sounded like an accent which sounded like a dark person calling, they used to reject the right itself. So this basically looks at, a very, very important aspect of bias, where we are saying that a specific race, just looking at their voice, could get an opportunity denied. And I think the same has been found in this example, which is over here, which talks about the resumes, and the African Americans actually got a low callback compared to the white names. So these are places where it is actually been found that the protected, so-called protected variables has an impact, and we need to carefully remove them from the system. Okay, so bias is not new. It's been there for decades, but I think the bias has got immense interest at this point of time, owing to the fact that there's been tremendous increase in the number of AI applications we see, and almost every aspect of our work or of our daily life has an impact by an AI system. Okay, so what are the type of biases that we see? I'm just going to put in everything and then walk through the thing. So if you look at it, because of this AI pipeline, there can be different kinds of bias. Like, look at the representational bias. It talks about that you can have a category of person denied or category of race denied. A category by means it's a group. A group, when you have a bias towards a group, it's called as a representational bias. There's called statistical bias, which means there is a statistical difference between the one that you trained on and the one that you had on the unseen data set. So there is a difference in these properties, then it can lead to statistical bias. The interaction bias is basically because there are different components in the AI system interacting with each other, and when the interactions do not convey the expected thing, then that can lead to bias. Okay. There is a temporal bias, which means over a period of time, you're observing that there is a bias as opposed to a single point in time in the kind of things that we observe in the real world. Proxy bias happens because you don't have the real data set, but you're simulating certain data sets, or you're having a near proxy of the actual sensors, and therefore they do not produce the real representation of what is being captured in the real world. So these are kind of different kinds of biases that are available, and for each of these biases there are mechanisms to identify them first, and second, to remove the bias from the AI systems. As I said, not all biases are bad. One example I had given you is the women's clothing store, where you definitely would like to see the women's clothing in that. So we have to be careful about types of biases we wanted to remove, and let's say, for instance, if you also look at the insurance thing, we need to carefully look at it whether a bias of certain nature where the age played an important factor has to be removed or not, because at the end of the day the businesses might get impacted because of that. So it depends on the context what we look at and how we wanted to mitigate the bias, what is the percentage of things we wanted to have influence on different category of things. So all those things are context driven and has to be carefully designed in the AI systems. This, I think we have gone through several examples. So as in philosophy, where it is like it compounds injustice or misfortune is when we don't want a bias in the system. And practically, when the bias does not provide the equal benefit to all the groups of the population, that's when we call the bias unacceptable. And I think we have seen a lot of examples in these two talks about where the bias actually impacts the thing. Okay, now I'm going to introduce this tool called AI Fairness 360. This is actually a tool that we have come up from the IBM research, and it is open source. There are links in this thing led from the Watson team, which you can actually look at it, download it, register, work with it, and I'm going to just walk through a few things, capabilities that it can do today, and it might help you in your research works if you're looking at data and seeing how you can reduce bias from the data. So this is actually a live tool that is available, which is in ai360.bluemix.mybluemix.net. You could actually go there and look at a few things that are of importance. It gives you a wide variety of information which is useful for people, for the first time beginners, as well as people who know bias and they want to use this toolkit for comparing their own bias algorithms with the existing bias algorithms that is been available as part of the toolkit. So we have roughly about 9 algorithms built into it, and there are about roughly, it measures 70 metrics on the AI systems, most of them related to bias and some of them in general for an AI system. There is a web demo that is available, which definitely you should try, which runs live on the data set which is available. A couple of algorithms, and it shows you the difference about how bias can be measured and how bias can be mitigated. This is the landing page of this AI Fairness 360 toolkit. An example, as what I have said, is basically it considers what is called as the protected attributes. In this case, it turns out to be sex as an individual, as an attribute. And there are a couple of metrics it shows. All of these are related to measuring biases. The statistical parity difference tells that between two groups of individuals whom we see, or the clear two different groups, are there equal number of people in the first group getting the same opportunity as the same number of people in the second group. So it basically measures are there equal distribution of opportunity given to both category of people. An example is that if you have 80 men and there are 20 women in the category of the data that you have, if 5 men get the data, 5 men get approved, is it out of 80, 5 of them are getting approved? So in the women, is the same number of people getting approved or not? If it is, then you would say there is the bias is less, and you could proceed with that. But of course, if it is not, then you basically have to find mechanisms to basically mitigate that. And that's what exactly the statistical parity difference does. So there are other bunch of metrics like equal opportunity difference, average odds difference, disparate impact, the index. So these are all measures for measuring the bias itself. And once you can measure bias, you can actually look at it and see if it is very high. You can go back and look at algorithms for mitigating them. So you can actually choose different attributes in the toolkit, and then you could basically go ahead and perform the experiments and see what are the kind of metrics that is there. And if you want a certain metric, you could look at that metric and see what kind of algorithms you could apply for bringing down that metric. Now AF360 has been in the news. There's been it was launched last year, and this year we have got a recognition for the brand image. So it's been widely covered in the media. I would request the participants here to have a look at this toolkit, and if you have any questions, to post it back. We do have a Slack which is given, the details of which is also available in the tool. To post it, connect with us back, and we'll be glad to help you drive from the AI systems, how you can look at bias, reduce them, and also provide some mitigation algorithms around them. So that's the plan for today, and I would request you people to have a look at this tool and get in touch with us, and we would be glad to help you all in using our toolkit in your systems for reducing bias. Thank you.
Thank you, Kalapriya. Really, it was really extremely interesting. I don't know whether there are any questions from our audience. it would be good really to have some comments from those who are working hands-on on computer programming and information systems. I would have plenty of comments without that specific backgrounds, but I think that just Kalapriya, that your speech was really answering to the to some comments that are often heard of in the field of artificial intelligence and machine learning, when there is just this comment like, okay, bias is there, is part of the corpora, it's part of the word, and therefore machine learning can just reflect it. But what you showed us actually is teaching us that this is not really the case, and that a lot can be done, that there are tools out there. I was also very much interested into the argument that you were building on trusting decisions by machines, and therefore having unbiased artificial intelligence as reflecting human values as a way to build trust. So this should really be of interest for all engaged in ICT research and industry as well. So thanks again. Nicola, maybe you have any comments? I see.
I'm wondering how the tool deals with correlations between gender and other categories, Kalapriya. I really love the talk, and I'm not familiar with the tool, so I just wondered how it deals with that.
Right. So, so that's a very good question, and I think very relevant in this thing, because if you look at it, if we say, for instance, if we have a data set, and if we say gender is the column that is impacting my outlook or output, can I just remove the gender column? Right. That's a common question that people put in for detecting bias, and I think the answer is not so always, because gender can be correlated with another variable, and the correlation could have been used in the machine learning algorithms for learning certain features. So there is a process of identifying bias in our toolkit, which looks at many factors, and it decides what kind of mitigation algorithms that we can come up with. And there are clearly three different categories of algorithms we apply to mitigate. One is called as the pre-processing. That is before the data gets into the model. Can we do something with the input data so that it reduces the bias? Like, say, for instance, do we want to change the labels? Do we want to change the distributions? You know, I mean, in order to make sure that the data is basically reflecting what a usual system should have, equal distributions across different categories. So that is one category of work, and it definitely considers there can be a correlation between things, and it applies many of the statistical inferences to basically look at modifying the data set itself, which goes into the AI models. The second category of algorithms is basically look at the AI algorithm itself and sees, can I understand that these are the certain things that is introducing the bias? Can I change, let's say, for instance, the feature vectors or the weights within the models, can they be altered so that they basically become de-biased? And the third category of algorithms we look at is, once the output comes out, can we look at this output and say, certainly this has certain bias in this thing. What can be done in order to de-bias this output, just looking at the output itself? So there are different categories of algorithms, and there are relevant research in each category of them, and they have been implemented within this toolkit. I can actually refer you to a paper that we have written in this thing, and it's available in the archive to go through it, and we can have a look at that information in detail.
Thank you. Thank you, Nicola and Kalapriya, for continuing the discussion. Actually, we have run out of our scheduled time. If there are no further questions, I would just wrap up without really concluding anything in particular. I think that all the issues have been covered in an excellent way. I'm really happy that we also managed to, thanks to your contribution, to really address the intersectional aspect of gender bias in ICT and IST. We got an amazing range of theoretical inputs as well as practical tools and toolkits to be used. So I really think that after this webinar, we are also going to expand and enrich the section of our EQUAL-IST toolkit on gender in ICT research content. We will also work out a questionnaire that we plan to send to all our participants today, asking you who are actively engaged in computer sciences and IS to reflect on the inputs which were raised today and try to apply them to a concrete and specific research project of yours. So this is an exercise that we are going to propose you within the EQUAL-IST project. Having said that, I just invite you to stay in touch via our website, where you can also register to our newsletters. I thanks again to our great keynote speakers. Thanks to the BioLabs team for an excellent technical and logistical support here on GoToMeeting. Thanks to you all for participating and interacting. Goodbye.